These are the notes for when we have a right triangle and then an altitude drawn from the right angle of the right triangle. In class, you derived three relationships that the length of A is equal to y times c square rooted, B is equal to x times c square rooted, and h is equal to x times y square rooted. Now remember, you did this because the little triangle, the slightly bigger triangle, and the whole triangle are similar triangles, and you derived these formulas using that fact. So let's do two examples. In our first example, we're given a triangle and we're asked to find x and y. Please note that on the PDF file for these notes, there is a missing right angle notation at the top of this triangle, so you'll want to add that. Otherwise, we can't apply the three rules that we derived in class. So I'm going to start by finding neither x nor y. And the reason for this is that I really actually want to know A right here. If I knew A, then that would give me X, and then it would make it a lot easier for me to find Y. So I'm going to remind myself that this length, 8, equals the square root of 6 times A. I'm going to solve this. First, I'm going to square both sides. And then I'm going to divide both sides by 6. Now, this fraction can be reduced to be 32 over 3. And I'm going to leave it as a fraction. Just, I'd rather not deal with the decimals, especially in this case since the decimal is 0.3 repeating or 0.6 repeating. So now that I know A, I can find X. And I can say x equals 6 plus a, but I know what a is. A is 32 over 3. I'm going to need a common denominator so I can add these two numbers. I can write 6 as 18 over 3. Number 18 divided by 3 is 6, so that's how come I can do that. I then add these and I get 50 over 3 equals x. My last step is to get y, and now I go back to the formulas we derived in class, which means that y equals the square root of 6 times x, 50 over 3. I'm going to simplify my fraction first, and so I have the square root of 6 divided by 3 times 50. Which is the square root of 100, which is 10. My second example is the same idea, but my triangle is actually sort of oriented in a slightly different way. It doesn't actually change what I'm going to do. It just means that I am looking at I'm looking at it from a slightly different angle. I'm going to find x first here. So we know that x equals the square root of the little times the whole, 6 times 30, which is the square root of 180, which simplifies to be the square root of 36 times the square root of 5, which is 6 times the square root of 5. I'm now going to find A. However, I'm going to have to actually find this small length right here. But because I know the whole thing is 30, I can simply subtract 6. So this piece over here is 30 minus 6, which is 24. So now I can say that A equals the square root of 6 times 24. And in this case, I am going to simplify this in a slightly different way. I'm not going to multiply first, and I actually probably shouldn't have multiplied first in this first one. But what I'm going to do is I recognize that I have 6, and then 24 is 6 times 4. So then I could rewrite this as the square root of 36 times the square root of 4, which is 6 times 2. So A is 12. Lastly, I'm going to find y. So y equals the square root of the piece, 24, times the whole, 24 times 30. I'm going to learn my lesson from between the first two that I did and say, well, what I actually want to do here is let's actually break this up so that I have the square root of 4 times 6 and 6 times 5. I can break this up to be the square root of 4, square root of 36, the square root of 5. So 2 times 6 times root 5. So 12 square root